how many layers are there in TCP/IP? So Transmission Control Protocol, Internet Protocol has 5 layers. Okay. Previously, or the counterpart is ISO OSI, International Organization of Standardization and Open System Interconnection. This is the model of 7 layers. Now, the makers of TCP/IP, they combined this APS, Application, Presentation and Session, and they made it into one. And other layer are still the same. The main idea of TCP/IP protocol stack is on whole internet. This TCP was used widely, Transmission Control Protocol, and network layer IP was used a lot. That is why the name of the protocol stack itself became the TCP/IP, because of these two very important and very popular protocols. These are actually the protocols, but the whole stack is named like this. Okay, now the first is the application layer. So we'll start with the application layer. Just understand you are interacting with the application layer, because application is all about the user working and trying to use the network service from where it will use. See, you and me are in, I am in India, you are in Nairobi. So we have to have certain network protocols, some certain rules, regulation that we need to follow so that we can talk on network. So the header, the trailer, the protocol, the fragmentation, the routers, hubs, all these follow certain protocols. That is how we are communicating. A whole world is communicating to each other. That is why we have this TCP/IP protocol stack. This is not real. This is actually logical. This is logical. Sometimes you may skip, your device may skip some of the layer if it doesn't require it, right? But certain layer, like the application layer, the way you interact, the physical layer, the bits are going, this needs to be there. But some of the layers, they may be skipped. But at the point of implementation, I'm just saying that these are the 5 important layers. You can remember it by AT-NDP, AT-NDP, AT-NDP. So coming to the application layer, here you are sitting in front of your system or computing device. This application layer is where the application and software need network communication to function. For example, your web browser, and you are requiring a service from, say, web service or web server. So here you are trying to access the network services, or you are trying to use the network options. So from where you will start? You start with application layer. So it will be a software, it will be a network utility. It may be something related to network. So that network layer service providing will only start with the application layer, because you are interacting, and the point you are interacting is called the application layer. We have various protocol, SMTP, FTP, Telnet, etc. Coming to transport layer, very important layer. Now this is responsible for process-to-process communication and end-to-end delivery. So the user has asked for certain network service. Now he has started some work. That kind of content will be coming to the transport. So application layer interaction will give rise to the actual data, and that data will flow to the transport layer. So these are the port addresses I am just talking about, because IP address is the specific address of a computer on the internet or on the intranet. But port is very important, because you are talking to this, you are not sending it to the system, you are actually talking to this process. So a web page will be talking to the process, the web server process on the other system. That is called process-to-process communication. So it is responsible to establish a reliable connection if you are using TCP, and fast connection, unreliable connection, which is UDP, with the application layer by assigning a port number of source and destination. So TCP, as I said, it is a reliable connection, and TCP, the content will be made, that is the bit stream coming will be made as TCP segment. The UDP, again it will add 8 byte of fixed header, and there will be a payload. So if you are using video call or voice call, UDP will be used, or you should use UDP. If you are actually sending the email or say file transfer, you need to use the TCP. There are other protocols also in the transport layer, but these are the most important one. That is why we are discussing. So please understand, this is end-to-end delivery, and then we have this process-to-process communication. Now TCP segment, UDP segment, the datagram we have prepared. Now it is coming to the network layer, and this is one of the most important part of the protocol stack. So the transport layer was having segments, TCP segment. Network layer will have IP packets. So it is responsible for creating data packets and adding a logical address, that is IP address 162.192.6.1. This is the IP address by which a host or a computer or a computing device will be known to all the other systems on this globe. Okay. First of all, the assignment of logical address and the routing traffic. So routing from source to destination, that is host to host delivery, is done by network layer, computer to computer delivery. And here most of the work is done by this IP, that is the basic internet protocol. Then we have ICMP, IGMP, ARP, RARP, all is there. So it is basically the router, which router it has to go, that is hop to hop delivery, and where it will go. Then the packets are being found. Now it goes to the data link layer. Now this data link layer deals with creating the frames. So it will also add the IP packet. Mostly the fragmentation part is done at this layer, the network layer, and now these are converted into frames. And the data link layer will add some header and also some trailer that moves across the network. So it performs physical addressing of data by adding MAC address to it. Now see, very important, network layer was assigning a logical address which was the IP number, but data link layer is adding MAC address. So physical address we are talking about, actual address. Every computer will have a networking card that is called as the NIC, network interfacing card, or something like that. And that will have a very unique number, MAC address, which is the physical address, actual address. Okay, which will be known or identified for source and destination. So data link layer making frames and then adding the MAC address, that is the actual physical addressing happens here. Then coming to the physical layer. Now actual bits and bytes will transfer from here. So the physical layer is responsible for encoding and decoding the data in the form of bits and defines the communication between two devices. It can be wired or wireless. So Ethernet, you can call the various network topology. All this is the work or is the responsibility of the physical layer. The physical layer will meet where? On the different machine, it will send the data. The different physical layer will accept that data, and then again this will go backwards. The other system will give these bits to data link layer. Data link layer will remove the trailer and header. The network layer above will try to find out the logical address, and the transport layer, the TCP, UDP, the ports, and actual application will be given the data.